Welcome to Lesson 1, Introduction to Organic Chemistry. Our lesson objectives: identify the properties of organic compounds, identify hydrocarbons based upon their formulas, name hydrocarbons using table P and Q, and determine if a compound is saturated or unsaturated. Organic compounds are compounds that contain carbon as well as hydrogen. And some major sources of organic compounds are petroleum, coal, wood, plants, and even animals like us. So what's so special about carbon, and why is there a whole lesson or unit associated with it? Well, that's because carbon has 4 valence electrons, as we can see here, represented by these dots. And therefore, in order to achieve a full valence shell, a stable octet, it's going to make 4 bonds. And since carbon always has 4 bonds, we can actually get pretty large structures being formed. Some properties of organic compounds: in general, they are nonpolar, meaning they're insoluble in water but soluble in other nonpolar substances, and that's due to like dissolves like, which we talked about in our previous unit. They're also generally poor conductors of electricity because they're not electrolytes. That means they don't form ions in solution. Organic compounds also typically have low melting points due to weak intermolecular forces of attraction between the molecules, and in general are combustible, meaning they are flammable. Let's check your understanding. Can you identify the properties of organic compounds? If an organic compound contains only carbon and hydrogen and no other elements, we call it a hydrocarbon. That's because it contains only hydrogen and carbon. That's where the name comes from. And so on table Q in our reference table, we have the homologous series of hydrocarbons. These are groups of organic compounds with similar properties and structures. And table Q gives us the general formula and some examples, including the name and structure of these compounds. So the title says homologous series of hydrocarbons. Again, hydrocarbons containing only carbon and hydrogen. These are the 3 series: the alkanes, alkenes, and alkynes. And so in a series, these compounds would have similar properties and structures. So the general formula has this N here, which is the number of carbon atoms. So if you're trying to figure out how many hydrogens would a certain number of carbons have, you can plug into the general formula. So this example here has 2 carbons. So if we plug in 2 here, 2 times 2 is 4, plus 2 gives me 6. So a structure with 2 carbons is going to have 6 hydrogens associated with it if it's an alkane. The alkenes have at least 1 double bond, and the alkynes have a triple bond associated with them. And you can see the general formula is different than the alkanes. Let's check your understanding. Can you identify hydrocarbons based upon their formulas? The next reference table we're going to look at is table P, and that shows us prefixes to determine how many carbon atoms a compound has. And so here is table P with all our prefixes. And so let's see some examples. So if you're given a formula C2H6, 2 carbons, we look on table P and we see that is going to be the prefix eth. 3 carbons is going to be prop, 4 carbons is going to be bute, 5 is going to be pent, 6 is hex, 7 is hept, 8 is oct, and 9 is non. And if you have 10 carbons, that would be a prefix of dec. So then how do we name these hydrocarbons? Well, we're going to put table P and Q together. So looking at table P, let's look at the prefixes first for these 2 examples. So 1 carbon would be a meth prefix, 2 carbons would be an eth prefix. Now we're going to use table Q for the ending. Since this has only single bonds, all single bonds is going to be an alkane, so the ane is the ending name for this series, so this would be methane. This example has a double bond. A double bond is an alkene, and so the ending is going to be ene, so this is ethene. Let's do the same thing for these 2 examples. So using table P, let's look at our prefixes here. We have 2 carbons, so 2 carbons is the prefix eth, and this example has 4 carbons, that's the prefix bute. Now let's use table Q. Since this structure has a triple bond is going to be an alkyne, so using the yne ending, so this is ethine. And for this example, since it's all single bonds is going to be an alkane, so this is going to be butane. Let's check your understanding. Can you identify hydrocarbons based upon their formulas, and can you name hydrocarbons using table P and Q? Now, how do you determine the type of hydrocarbon? What we're going to do is we're going to count up the number of carbons in an example. So if you were given an example C5H12, we count up our carbons. We have 5 carbons. And so here's a little trick. Using table Q, if you look at the alkene, the general formula is CnH2n, meaning it has twice the number of hydrogens compared to carbons. So if I look at my example here, 5 times 2 would be 10. So twice the number of hydrogens compared to these carbons would be 10. Since this is more than double, that means it has to be the alkane series because it is more than double. It's 2n plus 2. If it's less than double, it would be an alkyne series. So let's see some examples. C2H6. So using table P, we're going to get our prefixes. So 2 is eth, 5 is pent, 3 is prop, and 4 is but. And now, using our trick here, we look at the example and say, what is more than double of the number of carbons? So 2 times 2 is 4. Since this has more than double the amount of hydrogens associated with these 2 carbons, it can't be the alkene series, it must be the alkane series, because that general formula is more than double the amount of hydrogens. So this is going to be an alkane, and so the ending is ANE. This example here, 5 times 2 would be 10, so we have more than double the amount of hydrogens. So again, this is also an alkane series, and so this is pentane. 3 times 2 would be 6, so this is exactly double the amount of hydrogens compared to carbons, which is the general formula for our alkene. So this is going to be a propene. And then 4 times 2 is 8. Since this is less than double the amount of hydrogens compared to carbons, this must be an alkyne series because the general formula is less than double the amount of hydrogens compared to carbons. And so the ending is going to be YNE, so this is butene. Let's check your understanding. Can you name hydrocarbons using table P and Q? And lastly, we're going to talk about saturation. So compounds like fats that are saturated have many hydrogen atoms attached to the carbons. This requires single bonds. And so in our homologous series, the alkanes are the only series that has all single bonds, and therefore the maximum amount of hydrogens attached to it. So we say it's saturated with hydrogens. So we can remember this, that compounds that are saturated contain single bonds only. So therefore the alkenes and the alkynes, since they contain either a double bond or a triple bond, they are not saturated with hydrogens. They have less than the maximum amount of hydrogen atoms attached to the carbons, and so we say they are unsaturated. Let's check your understanding. Can you determine if a compound is saturated or unsaturated? At this point, you should be able to identify the properties of organic compounds, identify hydrocarbons based upon their formulas, name hydrocarbons using table P and Q, and determine if a compound is saturated or unsaturated.